Okay, we're on electromagnetic radiation, the bottom of page 3, where it says the wave nature of light. Electromagnetic radiation is abbreviated EM radiation, and it travels at the speed of light, 3.0 times 10 to the 8th meters per second, which you need to know. Examples of electromagnetic radiation are given in the figure in the following page, which you have to know. Okay, microwaves, ultraviolet radiation, gamma rays, radio waves, visible light are all examples. You need to know that wavelength has an abbreviation of lambda. Okay, it is the distance between peaks or troughs. Okay, and here it is right here. Frequency is the number of waves or cycles that pass through a stationary point in 1 second. So frequency, this would be high frequency, this would be lower frequency. Frequency has an abbreviation that looks like a V. Okay, so this is high frequency and low frequency. Okay, this wavelength right here would be shorter than this one up here, and you'll notice that wavelength and frequency are inversely related. Make sure you know that. So that means that the longer the wavelength, the lower the frequency. The higher the wave, the shorter the wavelength, excuse me, the higher the frequency. In terms of energy, frequency and energy are directly related. So if this is high energy, this is low energy. So the higher the frequency, the higher the energy. The lower the frequency, the lower the energy. You should also know that wavelength and energy are inversely related. So the longer the wavelength, the lower the energy. The shorter the wavelength, the higher the energy. Okay? The figure here, you don't have to know the numbers, but you need to know that this is the long wavelength side, this is the short wavelength side, this is low energy, this is high energy, this is low frequency, this is high frequency. You need to know all of the different forms of EM radiation, radio, micro, infrared, visible light, ultraviolet, X-rays, and gamma rays. Because I'm going to ask you things like which one has higher energy, which one has lower frequency, which one has a longer wavelength. Okay? You also need to know that visible light comes in these colors, and this is the order that they are from left to right in the handout. Red, orange, yellow, green, blue, indigo, violet. Okay. Now, you need to know that there is ionizing radiation. Examples would be X-rays, and this is typed up for you in your handout. You need to know that ultraviolet and infrared light are not visible to the human eye. Visible light, however, is, which falls between infrared and ultraviolet, which is kind of hard to tell here on the figure. They just sort of blew up this region right here, so you could see it better. And you need to know how microwaves operate. If you have a substance that contains water, then the water molecules are going to absorb the energy and they're going to heat up, and that's how your substance heats up. Student exercise number 10, arrange visible light, X-rays, and microwaves in order of increasing wavelength. That means you're looking from right to left for increasing wavelength. So it should be X-rays, visible light, and then microwaves. B, frequency. If we're looking for an order of increasing frequency, we're reading it from left to right. So we're going to put them in opposite order. So it's going to be microwaves, light, visible light, and then X-rays. C is energy per photon. Photon is just a term that we use to quantify the amount of energy that we're talking about. Make sure you know that. It's just a packet of light energy. And if we're looking for increasing energy, it's the same as what you wrote for B. So it would be microwaves, visible light, and then X-rays. The homework that you're doing for this section is here, electromagnetic radiation worksheet.